Now I am going to explain about properties of discrete Fourier transform in that Parsvels theorem. So the Parsvels theorem states that summation n is equal to minus infinity to infinity x1 of n, x2 of conjugate of n, which is equal to 1 by 2 pi j integral x1 of k, x2 conjugate of k into dk. Okay, so this is the Parsvels theorem. Okay, so in that x1 of k is equal to summation n is equal to minus infinity to infinity x1 of n e power minus j 2 pi kn by n. Now x2 of n is equal to what? 1 by 2 pi j integral minus pi, you have to take the limits of minus pi to pi, x2 of k into x2 of k e power j 2 pi kn by n. So this is x2 of n. So this equation is, keep it as equation 1. Okay. So from equation 1, right hand side of equation 1, that is what? 1 by 2 pi j integral minus infinity to infinity x1 of k into x2 of conjugate of k into dk. So here what is x1 of k? x1 of k value is this one. Then substitute 1 by 2 pi j integral. So you have to take the limits from minus pi to pi. x1 of k is what? Summation n is equal to minus infinity to infinity x1 of n e power minus j 2 pi kn by n, okay, into x2 conjugate of k into dk. Okay, now in this rearrange the terms. So this summation and x of n, you keep it out, then it becomes summation n is equal to minus infinity to infinity x1 of n, okay, then 1 by 2 pi j integral x2 conjugate of k into e power minus j 2 pi kn by n into dk. Okay, so this is summation n is equal to minus infinity to infinity x1 of n. What is this value? This is x2 conjugate of n. Okay, now 1 by 2 pi j integral minus pi to pi. So you have to take the limits minus infinity to infinity or pi to pi. x1 of k and x2 conjugate of k dk, which is equal to summation n is equal to minus infinity to infinity x1 of n into x2 of conjugate of n. Okay, so this is the Parsvels theorem.